of this event, because I always feel that I'm an over-educated administrator nowadays, but not in those days, but since 20 years. But right now, when I was out and in, I was even listening my colleagues through YouTube, because on YouTube you could stream all of the presentations. So I'm very happy that now I can share my ideas. So my presentation is about the AI servers and the expanding demands of AI servers and the social challenges to AI servers. And the title of my presentation is AI servers expanding energy demand, societal challenges and EU policies approaches. So what I would like to talk about today. AI promises for us social benefits, health, education, but at what cost? The question is the rise of the energy cost, and not only the price of the energy, but at the same time we have to evaluate the social costs what we pay for AI. The big question is, there are certain scholars who have written that AI aids the world. There are lots of critical scholars, even Harari, who were writing about that the danger of AI, the AI shall change the world, change the history, which can be partly true. But at the same time, I'm trying to focus on the energy part and the justice aspects of these whole questions. AI data centers are expanding quickly. Electricity demand and social equity concerns comes with that. My big question, and Franz Krauss, the Nobel Prize laureate, the scholar in Hungary, the study starts with a good question. Is AI make society better? Are we sure? Once, when we're talking about the cost of energy, and also we don't have to forget the environmental impact which comes along with the use of AI servers. Of course, not only AI servers, but we're talking about AI servers now. We've been already talking about numbers, I just would like to highlight a few numbers. 1.5% of the global electricity consumption shall be used for running AI servers, but it can reach up till 3% by 2030. And the growth of AI-driven servers are increasing 30% per year. And therefore, when we would like to train and we put informations in these AI servers, the large amount of data we are handling is growing day by day. There has been recently several quite thorough researches related to that. So I tried to find some examples of certain countries. Correct me if I'm wrong. For example, in Ireland, 20% of national electricity now used by data centers, and there's been a significant increase recently. The EU demand between 2023 and 2026 has been increased by 30%, and it can also increase by 70% by 2023. So, what can we do, and what's the problem when we're talking about generative AI, and how does it work? When we're talking about the large-scale GPUs and accelerators, which runs often 24/7, not only the electricity consumption, which a lot, but also we have to heat, cool those computers, and the surrounding infrastructure can use in certain areas, certain countries, up to 30% of the electricity consumptions. And what are the main power sources of AI today? Well, right now, if you see the global energy mix, we run AI servers from renewables, and of course, we still use classic fuels like natural gas and also coal as well. In the EU, the EU policy target that climate-nature data centers, we should install climate-nature data centers by 2030, which still seems to be an illusion. And at the same time, there's a rise for the interest of deploying new nuclear reactors. There are several projects, they called SMR, the small modular reactors, and especially there are certain companies who are willing to deploy these projects, and there are some initiatives in Poland and in Britain as well. But the problem is right now, for example, in Hungary, I'm not sure that the acceptance of these small modular reactors, especially from safety perspectives, are accepted by the society. And of course, we still facing several licensing issues at the same time. And it's not only the problem. When we have the peak hours, peak times, especially cooling down the server parks, we also fall back to gas or coal at the same time. And that's not only the problem. If you would like to reach 100% renewable for AI servers, sometimes it's not simply possible. During daytime, a certain time of the day, we can reach, of course, lots of energy from photovoltaic power plants, but still there's a huge mismatch. Certain time of the day, we just simply cannot produce enough energy from those sources. And therefore, the risk which I would like to highlight, that AI and also data centers absorb a large share of renewable energy right now. This is how we call crowding out, we can say that. So right now, the problem is that the energy policy needs to be adjusted and ensure that the clean energy capacities, what we have right now, shall not be completely relocated for AI servers and for server parks as well. Who pays the price? If we're talking about, we are not only talking about the price of the electricity or the availability of green sources. There's a huge stress on the grids, and the grids are not for the development of the power lines. The grids are simply not followed by the demanding need of AI servers in Europe, and therefore there's going to be a price. And sometimes in certain areas we are facing several critical issues with the lack of capacities of power lines and transformator capacities as well. I've just evaluated in certain countries, for example, Ireland, a bit. There were significant problems, and there are also limited cross-border capacities, at least the peak times, and when we would like to import even green energies from other countries. It's a general problem in Europe. And the main focus point of my research, and I think I'm going to elaborate it in details in a paper, which actually we would like to publish a paper afterwards, after this conference. We shouldn't forget that. That energy poverty, there's this huge social justice problem, the double inequality risk, which I would like to highlight right now in this presentation as the focus point of my research, that it's quite sure that energy poverty is rising and has been rising for a long time in Hungary. More than 10% of the EU citizens are unable to keep their homes warm. In Hungary, it's a bit special because we have a special regime. It's called rezsicsökkentés, which tries to keep, it's like a block tariff system, which tries to keep a certain amount of energy and gas and electricity in a reasonable price. But in the rest of Europe, the rising of the energy and electricity prices creates major problems. As Peter Cover mentioned yesterday, it's a very huge problem in Europe and still. So when we would like to find energy poverty, we don't have to go to Africa. I fully agree with that. And the low-income households pay, of course, can pay the price, and of course, the lower-income part of the society shall pay much more price for that. So when we're talking about the equity question, the AI shall help to enhance our life, to have better life, and if the price of the AI shall increase, because of course at the beginning it was quite free, then in half year later we pay 20 euros. Now there are 200 euros model, and then there's a 2,000 euros model, and probably there's going to be the $1 million model, which helps your life, enhance your life. But at the same time, due to the fact that the energy price shall increase in the future, it definitely shall increase, then the poorer part of the society will not be able to buy and purchase the necessary part of their energy, necessary amount of energy what they need. So then, it's like a double penalty. a double inequality, a double risk, because lower income society shall be more poor, shall have less access for AI, for sure, and at the end of the day, they shall benefit, I wouldn't say zero, but very little from those advantages which can be provided by AI. But at the same time, they shall pay the price for this whole AI trends. What we can do, just not to waste time, we have to see both sides. Of course, there are economic and productivity gains on the left side, I would say. And another thing, and I was also talking about in e-waste, because with the very short life cycle of AI servers, we were not only talking about energy and electricity use and the use of water for cooling as well, but when we're talking about the circular economy aspects as well, the waste which has been created by the rapidly changing technology of AI servers, it is going to be a very, very huge problem as well. We see what brings the future. For example, if I'm just referring to the new EU regulations related to the recast of the Circular Economy Act. So what we can do, we probably have to introduce my proposition, or we have to consider to change the tariffs and maybe make some tariff reforms. Cost causation, it means that these huge data centers probably have to contribute more to the grid cost. So it's not fair that a small and medium enterprise pays the same price for the same electricity than a large server farm. That could be, I know it's a very difficult question, but the legislators should carefully evaluate that question as well. In EU, there's a social climate fund which tries to help low-income families also. And as my last proposal here, which maybe some tech companies would I'm sure that they not agree on that, but maybe we have to introduce, or we have to consider to introduce a certain tax on AI servers or AI capacity or AI counting, and then this money should be allocated to social climate funds and other social programs, because otherwise, if we let to use or clean renewable energy by these server farms, then we should, and if the energy price and the grid tariffs are increasing, it's fair. We should turn back certain amount of profit for those parts of society who just simply lag behind and who are just not able to participate in that transition. That's all for now, and I hope that if we try to find the right mechanisms, the social return on AI, then most probably we can have the right balance between the productivity gains against energy consumption, e-waste, and equity problems on the society. Thank you very much for listening to me, and have a nice afternoon. Thank you.